Next we will study regarding some integral surfaces passing through a different some given curve, and we should remember that uxyz c1, what we have written many times beforehand, and vxyz is equal to c2. These two, both of them are two integral curves, and the auxiliary equations of that PD, then the solution, whenever these are the auxiliary equations, then the solution of the PD can be written as in the form of if u v is equal to 0, and if we are given some particular conditions, we can incorporate them, and then we can find out the particular surface which is going through or which passing through some given curves. So some problems will make the idea clear. So the problem is saying that find a curve, find an integral surface of the linear partial differential equation which is containing the straight line x plus y is equal to 0, z equal to 1. Now to do that, first we solve this differential equation as dx, again the auxiliary equation, dy minus y x square plus z is equal to dz x square minus y square into z, and we will take the first, we will take all these three things and we will multiply all of them by x, y, z. If both the numerator and denominator we will multiply in the numerator only, and this will give, see, yz dx, zx dy, and xy dz, and in the denominator what happens, this is equal to, this cuts off, and then y square z minus x square minus z plus x square minus y square. So this cancels out, this cancels out, and this cancels out as well. So this numerator is equal to 0 actually, because this combination is actually equal to the one fraction multiplied with xyz, and whatever be that value, as the denominator of this particular fraction is equal to 0, then the cross multiplication will give us this thing is equal to 0 directly, that is x, y, z is equal to some constant. And next we will take the multipliers. For the first ratio, we'll multiply by x, this by y, and this by z, and then we will find this will be x dx plus y dy plus z dz, and again we will see that this part will now again turn to 0, and ultimately we will have x square plus y square plus z square is equal to c2, and combining them we can write our function like f of this and this is equal to 0. But there is given another condition, that this surface, the surface which is given by xyz is equal to constant, and x square, y square, and z square is equal to constant, that should contain this particular straight line. Now for the curve, given curve, we will make a parametric form as we have seen that x plus y is equal to 0. So we are taking x is equal to t, y is equal to minus t, and z is equal to 1 as it's given as. And so this first equation that will give minus t square is equal to c1, and the second equation is giving us 2t square plus 1 is equal to c2. Now this gives that 1 minus 2c1 is equal to c2, or 2c1 plus c2 minus 1 is equal to 0. See, this is a relation of c1 and c2, right? That particular equation what I have already mentioned previously, that you should have to find that there will be some relation between c1 and c2. And now we will incorporate our results, that is c1 is xyz, so 2xyz plus c2 is x square plus y square plus z square, and minus 1 is equal to 0, and this is the solution. Next, another problem of the same kind. Again, we have to find another integral surface for the linear partial differential equation xp plus yq is equal to z, which contains the circle which is defined as so the auxiliary equation is dy by y dz by z. So simply see, this is log x by log equal to log y, so we can write it as x is equal to c1 y, and similarly y is equal to c2 z. Now this can be combined as f of x by y by z is equal to 0. Now we will match with that result that this particular circle is lying on this surface. How? So the equation of circle is already given, and using the already found out result we can obtain that c x square plus y square plus z square is given to be equal to 4. Now put all those results, x square is x square, and x is equal to y is equal to x1 by c1. Now this is x square by c1 square, and z is equal to, again first this is y by c2, and y is equal to x by c1, so this is x square c1 square c2 square is equal to 4, or rather x square 1 plus 1 over c1 square plus c1 square c2 square, this is equal to 4. And from the second equation, that is x plus y plus z is equal to 2, we obtain 1 plus 1 over c1 plus 1 over c1 c2 is equal to 2. Now see, this is actually a relation, and we can eliminate x from there. So 1 plus 1 over c1 square c1 square c2 square over 1 plus 1 over c1 c2 square is equal to 1. Or simply we can write it there, and see, there is a term, this is a square, and there should be a term 1 plus c1 square and 1 plus c1 square c2 square, so these will be cancelled out, and 2 over c1 plus 2 over c1 c2 and 2 over c1 square c2, and that thing is equal to 0. So c1 square c2 is equal to 0, and there this will be c1 c2 c1 and 1. So ultimately c1 c2 plus c1 plus 1 is equal to 0. This is the relation between c1 and c2, and we will write c1 is equal to xyz and c2 is equal to c1 is equal to x by y and c2 is equal to y by z, and we will obtain the equation which we need to do.